So I'm going live now on YouTube so that we can have dual processes going. And these are going to be oxidation reduction problems in basic solutions. So that's what I'm actually doing now. Okay. So let me make sure it is up. Yep, it's up and running. So let's go ahead and get back into it. All right. Yes, I am back. I'm back in the building, guys. Again, my charger went out, so I had to go back and restart, but I am back. So for this particular problem, for those of you all that are new to me, my name is Professor TK the Chemist, and I go live Monday through Thursday, 12 noon Eastern Standard Time. And so for those of you all that are at the end of your semester now and you're having trouble, this live is for you. I know so many of you guys are stressed right now because it is the end of the semester. And guess what? It's not going to get any better if you don't reach out to your professors, to your teachers, to let them know your concerns. Remember, closed mouths don't get fed, okay? You got to remember that. Now, having said all of that, I know that some of you guys are getting to the end and you may be on electrochemistry, or you may need this for the MCAT, for your AP chemistry exam, which is happening next week, for your honors chemistry class. Whatever chemistry you're taking, you may be needing this information right now. So what I'm going to do is walk you guys through a couple of practice problems that deal with oxidation and reduction in basic solutions. Last week, we dealt with this. We dealt with oxidation numbers. I gave you all several examples on how to do those. And then I also went over oxidation reduction problems in acidic solutions. So today, we're actually going to do basic solutions, okay? So I'm going to kind of zoom in a little bit so you all can see that, okay? And I'm going to walk you through this example on how to do problems of this nature that deal with redox equations, okay? So one thing I probably need to go back and redo, okay, that you would have to go back and do is look at your notes that deals with net ionic equations. And what does that mean? So there are two things you would need to know in order to do these kinds of problems, okay? If you look at examples like this, okay, one thing you have to know is that if you have your cathodes, okay, because this is going to help you to know how to write these reactions out. Cathodes is when you have, let's say you're looking at zinc, okay? Cathodes is when you're gaining electrons, and when you gain electrons, as a result, this is where you have, let's say again, the example of zinc with the +2 charge. You would say 2 electrons to cancel them out, and you would be left with, let's say, zinc in this particular example. If you had, let's say, an anode like, let's say, copper, okay? An anode, as an example of like copper, you're going to lose those electrons. And if you're losing those electrons, that means you have copper, for instance, like this, where you have a 2+ charge. You're going to show that you would have to add 2 electrons on the other side in order to cancel them out, okay? So when it comes to your reactions and how you write them out, depending on what's gaining and losing, that determines what you would write as a result, okay? So I'm going to erase this part right here and get straight to our example that we have above, okay? So make sure that you guys go ahead and tap that screen, tap, 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 okay? Tap, tap, tap. And what you need to do, thank you, Caitlin. What you need to do is to share this out with your friends or anyone that you know that is taking chemistry right now, because we are down to the wire. We're down to where so many students are stressed out. They're stressed out and they don't know if they're passing or failing their classes. But what I want you guys to do is to breathe in, breathe out. This could be general chem too, depending on what you guys are doing. Yes, thank you so much, Caitlin. Appreciate that. Yes, yes, yes. Yes, Jordan, you said I'm stressed out. Yes, I'm sorry y'all are stressed out because I know some of my colleagues don't do right by my students or by the students. They don't. I get it. And I've tried talking to my colleagues and saying, you know, don't be so tight with them, but who am I? Just another favorite chemistry professor. Okay. Some of these students be wanting to take my class. They actually withdraw from their chemistry teachers when they can't get into my class. And then they try to get into mine. And I'll usually override it and say, yeah, you can come on through. I don't mind. Because, sometimes the numbers kind of like work themselves out. Mark says, how can I best prepare for the General Chem 1 final? And Amina says, I have ACS Chem final on Wednesday. I'm terrified. Okay, guys, here's what I would recommend that you do. Get you a pack of note cards, depending on how much time you're willing to put in. You need to get you some note cards, a pack of note cards like this. You can go to Dollar Tree, and that's where I got these from. Okay. When you go to Dollar Tree, you can get the color-coded kind if you're a color-coded person, where on certain colors you put certain formulas on it from certain chapters. But I recommend that if your teachers are telling you or your professors are saying you are not allowed to have a cheat sheet, such as for the AP exam and things of that nature, they will give you formula sheets. But in the case of many students who are not allowed to have extra sheets with them, write your formulas down. And when you have spare time, just look over them. And then on the very back side of your note card, write out an example or paste an example on the back of it. So that way you're able to focus on smaller amounts of information. When you have a notebook full of stuff, it sometimes will cause you to get stressed out and you don't know which way you're coming or going. Okay? I'm learning stoichiometry and I'm so confused. All right, Jordan. Well, you know what? What I'm going to do, I'll probably start that on tomorrow. I'm going to start doing a review. Oh, you're welcome, Amina. I'm going to start doing a review where I allow students to ask me questions. So I'm going to dedicate, the first 30 minutes to General Chem students, General Chem 1, and then the other 30 minutes to General Chem 2. But it's going to be a review really for everybody. Okay. So everyone that's having trouble, you can always use the extra tips and tricks that I'm going to show you all throughout the week. So I think I'm going to actually go back and start reviewing things from the very beginning of the semester to now. Okay, Jordan, come on through, honey. And if you all want to go back over these things, you all can go check me out on my YouTube channel. And that link is up in my bio. And you can tap somewhere up here, somewhere. Okay. And it'll take you straight to my channel. And by all means, follow along and tell a friend to tell a friend. Now, what I'm going to do, yes, Leo, I do have some videos on that. And one of the things I can express to you is that you got to start off with what you need or what's given in the problem versus what is required in the problem. And if you have all of your molar mass calculations and all of your units for what you're trying to actually get to, that actually helps you along the way when it comes to differential analysis. I tell students all the time that if you start off with a gram of something, and then you're going to, let's say, a mole of something, you always want to take the unit that you start with, put that on the bottom of the other one so they can cancel out. And then if you're going to the mole of something else, let's say the mole of A to the mole of B, or a mole of B to the mole of A, you also want to continue to cancel those other things out until you get to what you're trying to get to. But I can actually give you some practice problems like that this week. So if you just hang on with me, Monday through Thursday, 12 noon Eastern Standard Time, I can give you further tips, okay? You're welcome, Leo. I know that was kind of like a quick, fast example, but yeah. Now, I'm going to actually go ahead and go through this problem with you guys, okay? And as you guys, I don't know if you all can hear me, but I am congested, okay? I'm a little under the weather. I'm going to be all right. So I just want to kind of give you all some examples on electrochemistry, and we can be good with that. Okay, Jenny, I hope you did well. And Wendy, if you just started chemistry, or if you're starting chemistry next week, come on back through my channel on YouTube, Learn Chemistry with Professor TK the Chemist, or you can also follow me here on TikTok and you can get some help as well. All right. So, oh, wow, Lindsay, I'm sorry. So let me go ahead and show you guys how to do this problem. Good luck, Angie, on taking your chem final tomorrow. Good luck. So if you have a reaction like this, and they're telling you that it's in a basic solution, one of the things you got to keep in mind is that, well, extra tortas. You recently dropped out of general chem. It was a hard decision, but I would have gotten a C. Okay, well, they say C's get degrees, but if that's your major, then that's a different story. Yes, a totally different story. All right, so for this particular problem, I'm going to go ahead and break it down for you all. This solution is in a basic solution. So here's what you have to do. In order to do a problem that requires you to formulate an oxidation reaction problem with basic solutions, there are certain rules you need to know, okay? Certain rules you need to know. And I'm going to kind of break those rules down for you in oxidation and reduction for basic solutions. Oh, yeah, I got you on that. I understand that. For inorganic chemistry, yeah, okay, thank you. Yeah, I'm telling you, it's like what I said before. You got to write down those formulas and write down those rules. Matter of fact, it's funny you say inorganic chemistry. I'm actually in my office right now, and this right here is my inorganic chemistry book from undergrad. I kept all of my chemistry books. Okay. I kept all of my chemistry books. Inorganic is kind of similar to just regular chemistry, but you got to write, just go back through your notes and start highlighting things that did not make sense to you and go through things that you wanted to understand better, rewriting those notes over. That's what I would recommend. All right. Thank you, B. Rivera. Sorry, guys. Woo. All right. So now for this particular problem, okay, in order to do basic solutions with oxidation and reduction, first you want to write the formula equation followed by an ionic equation. Of course, you then want to assign oxidation numbers to each of the elements, okay? So let me show you all that first step, okay? I'm going to show you all that first step. So right here, okay, you've got iron. Notice how you have the iron written out, okay? I'm going to write iron, Fe, S, and then I'm going to say it yields Fe2O3S. This one, guys, is an oxidation reaction. And I'm going to explain all of that, okay? Then you've got your chromate, okay? You got your chromate. This is actually the CrO4 with the 2 negative charge, and that's aqueous. And then that yields Cr2O3, solid. And again, this, ladies and gentlemen, is the reduction reaction. So what are you going to do? All right, when it comes to balancing out basic solutions, you've got to add water to the side that is lacking the number of oxygen atoms, okay? So in other words, if I take a look at this first reaction up here with iron, notice that the one on the left-hand side over here doesn't have oxygen with it, meaning you have Fe that produces Fe2O3. And if you notice also, you have 3 oxygens on the right-hand side, okay? So what you're going to have to do is add 3 H2Os to the left-hand side in order to give you your 3 oxygens. Of course, that's going to give you extra hydrogens, okay? And because it gives you extra hydrogens, I'm going to show you all what to do in that regard. So again, because I needed to balance out my oxygens, I have 3 on the right-hand side. I needed 3 on the left-hand side. I ended up adding 3 water molecules to give me the 3 oxygens that I needed. And of course, that resulted in having 6 hydrogen atoms. Now, the next thing that I'm going to do is I'm going to basically rewrite this equation out so that you guys can see this, okay? So I'm going to rewrite the top one. That's Fe solid plus 3H2O liquid yields Fe2O3, okay? Now, what I also need to point out too is that when you noticed here, you have to assign the oxidation numbers. And I know that oxygen has an oxidation number of -2. And I know that because of that -2, that's going to give me a different number of oxidation numbers for iron, which is going to be +3, okay? So what am I going to do? I'm going to add 6 electrons over here to the other side, okay? Now, the next thing we're going to have to do is rewrite the bottom equation, this next one right here that I'm going to put a little yellow star by, okay? So we've got CrO4 with a 2 negative, okay? Aqueous plus. Now, here's the deal when it comes to your basic solutions. You have to add hydroxide ions to balance them out, okay? So I'm going to leave a line there, and then I'm going to draw an arrow, and I'm going to write Cr2O3, okay? Now, what you're going to do, remember, you've got 3 oxygens on the right-hand side, okay? But you've got 4 on the left-hand side. So what are we going to have to do? We're going to have to add 1 more water molecule over here on the right-hand side in order to balance out the oxygen atoms, okay? Again, and let me erase, I'm going to erase that 6 electrons for right now, just so I can make sure that you guys can follow what we got right here, okay? I can, Carrie, I can. If you got any, DM them to me. So now you've got to, we're balancing out our water molecules, okay? Or our oxygens rather, all right? So let me show it to you again. If you remember up here, because someone had asked this question a second ago and I just saw it. You've got your 3 oxygens on the right for the first reaction. So let me number them so you all will know what I'm talking about. So equation number 1, equation number 2. All right, equation number 1 had 3 oxygen atoms. On the left-hand side, though, there weren't any. So to balance each side with the appropriate number of oxygens, we had to add water molecules. And in this case, we added 3 H2O water molecules to give us the 3 oxygens that we needed. For the second reaction, for number 2, we noticed that there are 4 oxygen atoms on the left, but we only have 3 on the right. So we have to add 1 more oxygen atom on the right-hand side. But in order to do that, you have to actually add water molecules, okay, for basic solutions. So that's what we write H2O, okay? So what I'm going to do now, I'm going to rewrite both equations down below, okay? So as you can see right here, I've got CrO4 with a 2 negative. The yield is Cr2O3 plus H2O. Now, here's what you're going to have to do, okay? You're going to have to now try to figure out how to balance out your irons, okay? We're going to balance out our irons now because what we currently have is in equation number 1, 1 iron on the left, but we've got 2 ions on the right. So what are we going to have to do? We're going to have to put a 2 in front of this particular reaction here, okay? So I put a 2 right there, and that's going to give me my 2 ions. But now, you have to remember, when I put the 2 there, okay, that means I'm going to have to do what? I'm going to have to also balance everything else out as a result, because we have to deal with those hydrogens. And we have to remember to write those hydrogens in as well, okay? Because we can't forget about our hydrogens, all right? So over here, I'm going to end up writing my 6 hydrogens here, okay? But in chemistry, when we write this out, we're going to end up writing out in this manner here in order to cross everything out that we don't need anymore, okay? So we've got our 2 hydrogens, I'm sorry, the 2 ions on the left, 2 ions on the right. We've got 6 hydrogens on the left, 6 hydrogens on the right, 3 oxygens on the left, 3 oxygens on the right. And now for the last part on the second equation, we've got our chromates. We've got 1 chromium on the left, but we've got 2 on the right. So you guys know what we need to do, right? We need to add a 2 there. And when we add the 2, that gives us our 2 chromiums on the left. Now, of course, this is going to change some other reactions around, because if you notice here, we've got our 4 oxygens on the right. But now, because of that 2 being in front of that compound, that means we now have 8 oxygens, okay? And because of that, in chemistry, when we're dealing with basic solutions, we've got to add hydroxide ions, okay? And this means we're going to end up with 4 of those. And why 4? Because we had a total of 8 on the left side, but we've got to balance them out also as a result of that, okay? And now we're going to have to go ahead and balance out our hydrogens also. Because remember, balancing equations with net ionic equations is no different than just balancing out a regular chemical reaction. Okay? It's the same thing. The same thing. And now we're almost done with our reaction. So what you're going to do is see if there's anything that can be canceled out. And right now, I don't see anything at the moment. Let's see. We're going to rewrite this equation out to see what we have left over, okay? And there will be some things that will cancel out as a result. So we're going to end up with 2 Fe solids plus 2 CrO4 with a 2 negative charge, aqueous, plus 2 H2O, liquid, producing Fe2O3 plus Cr2O3. And I forgot to write solids for that. Solids for this one as well. Plus 4OH negative, okay? So this is how our reaction is balanced, all right? So any questions about this particular problem? Okay. All right, guys. Well, if there aren't any further questions, I am going to log off because my time is up. I go live Monday through Thursday, 12 noon Eastern Standard Time. Starting tomorrow, I will start to go through things from the very beginning of the semester. So that means density equations, writing out chemical formulas, balancing equations, stoichiometry. So there's a lot that we're going to actually go through to make sure that we can get you guys back on the right track, okay? If you guys have any further questions, make sure you all go back to my last video and write your comments out on what you need further help with, and we can get your questions answered. Okay? All right. So you guys have a wonderful rest of your day, guys. Take care.